Okay, everybody, here's the next video. All right, so let's do some dividing. The first thing you'll notice is that, 8 does not divide evenly into 26. Okay, so that's what we're doing here. So let's, just see what we get here. So we'll go, okay, does 8 divide into 2? No. Does 8 divide into 26? Yes, 3 times. 3 times 8 is 24. And we'll subtract, of course. And there's nothing else to bring down, but our remainder is not 0. So one way to approach that, not the only way, is to slap on a 0.0 and then bring that down and say, all right, does 8 divide into 20? Yeah, twice. And so let's see, 2 times 8 is 16, and subtract. Wait, that's not there, it's 4. Okay, again, we don't have a 0 remainder, so I'll slap on another 0, bring it down, because after all, 26.00 is the same thing as 26. So 8 divides into 40 5 times, and 5 times 8 is 40. And now we get a remainder of 0. Okay, now, so now what do we do? Well, remember, 26 divided by 8, I mean, 24 divided by 8 is pretty close, and that's 3. So we should expect our answer to be around 3. But we're not dividing into 24, we're dividing into something just a little bigger. So we expect our answer to be a little bigger than this 3. So 325 is clearly not the right answer. So remember how I said with multiplication, you don't have to keep the decimal points lined up, but you do with addition and subtraction. You also need to with division. So the decimal point would just go straight up right there. And our answer is 3 1/4, which makes sense. It's a little bit bigger than 3. Or you could get that same 3 1/4 by not adding on the zeros, but then stopping right here and saying, oh, well, it went in 3 times with a remainder of 2 and a divisor of 8. And 2/8 is the same thing as a quarter. Oh, there it is, 3 1/4, 3.25. So you can write it as a decimal, you can do it as a mixed number, whatever. Okay. All right, now let's do another one. So this time we've got 8.99. We're gonna wait a minute, and we're gonna divide that by 0.62. Okay. So this time we're dividing by something that is, well, it has a decimal in it. So here's the technique. Okay. We're going to take, there it is. We're going to take that decimal point on the outside and go and just move it to the right until we end up with something that doesn't need a decimal point. So if I go there and then there, I end up with just 62 if I put the decimal point right there. Okay, now I can't just divide this number by 100, because that's essentially what I'm doing when I move it 2 decimal places. I'm going to have to do the same thing to this guy. So whatever I do to the number outside, I have to do to the number inside, and that'll put the decimal point right there. Okay, so let me grab my little eraser. So it's going to end up being 62 divided by 899. Right. And so we'll, different color. Okay, so does 62 divide into 8? No. Does it divide into 89? Yes. 1 time, so I put it right above the 9. And then 1 times 62 is 62. And I subtract, and I get that. And I bring down the next digit. And let's see, does 62 divide into 279? I'm going to guess 4 times. Let's give that a try. So 4 times 2 is 8, and 4 times 6 is 24. And yep, when we subtract, we'll get a number less than 62. In fact, 31. So at this point, we could stop and say, oh, my answer is going to be 14 and 31 60-seconds. And 31 60-seconds is the same as 1/2. So 14 1/2. Or we could slap on an extra 0 here and bring that down and say, all All right, does 62 divide into 310? And the decimal goes in. Yeah, I don't know, I think 5 times. So 5 times 62 is exactly 310. And we get a remainder of 0, so we know we're done, and 14 and a half. So there it is. Okay, did I hit record? Oh, I did. Okay, so we're live, or I am. So evaluate the expressions. We've got -3 divided into, well, first of all, okay, we've got a negative divided by a negative. Well, that's a positive. So I can ignore the signs. All right. So 3 into 1.89. This number out here, well, there's no decimal in it, so I'm not going to move any decimal points around. Okay, but this decimal point does go straight up, and 3 does not divide into 1, but it does divide into 18. 6 times, so 6 times 3 is 18. Subtract. Bring down the next digit. Does 3 go into 9? Yeah, 3 times. Subtract. And we're good. So 0.63 is our answer, positive 0.63. Okay, now the other one, we've got a positive divided by a negative. So I just know right now the answer is going to be negative. Okay, so that's cool. But when you divide by a power of 10, remember, all you got to do is make it smaller by moving the decimal point to the left one place. So it's going to be 2.994. Now you can do the division like that or whatever, but all the cool kids are going to just do it in their head. Okay. Well, there's my dog barking again. Okay. Anyway, that's how it's done. Okay. Yeah, the dog's still barking. Okay. Mary cut a wire into 4 pieces. The wire was originally 7.92 meters long. How long is each piece? Okay. Oh, equal pieces. Okay. I was going to say, it needs to say that. So we're going to take 7.92 meters of wire. Again, a meter is a little over a yard. We're going to chop that up or divide that up into 4 equal size pieces. So 4 goes into 7 once. We subtract, bring down to 9. 4 goes into 39 9 times. Subtract. 4 goes into 32 8 times. And so each piece is going to be 1.98 meters long. So about 2 meters, just a hair under 2 meters. Okay. And that's what I do. Okay, so next one. A tree in Anne's backyard is 4.83 meters tall. If the tree grows 0.7 meters each month, for how many months has the tree been growing? That might be a little confusing. Here's another technique I do sometimes to make it a little easier for myself. Sometimes I'll just say, you know what? How about if I just change their numbers for a moment, just to get comfortable with the problem? Change their numbers to something a little easier. What if I said, I don't know, maybe it's 10 meters tall and it grows 2 meters. No decimals, no fractions, just nice, easy stuff. So what would it, so a tree is 10 meters tall. It grows 2 meters each month. How many months has the tree been growing? You might say, oh, it's been growing 5 months. And you would be right based on the new numbers. Well, but how do you get 5 months? And that's what you have to ask yourself. Okay, how did I get the 5? And your explanation can't include the number 5. It cannot include that. You can't just say, well, 5 goes into 10 or 2 times. Whatever. You can't use the number 5 in your explanation. You have to say, well, that number divided by that number gives me that. Oh, so, whoops. So that means that number divided by that number would give me the answer. And I just do the exact same thing. Okay. Oh, I got to move this decimal point over. One decimal place. So that means I got to do it to, whoops. I got to do it. So I'll put it there. So I don't really need it. And then I got to move the other one over to there. So it's 7 into 48.3. Well, 7 into 49 goes 7 times. So this should be about 7. So 7 into 48 is 6. multiply and get 42, subtract, bring down the 3. 7 into 63 goes 9 times. 63, subtract 0, and the decimal point goes straight up to there, and we've got it. 6.9 meters per month. And these would be the units, meters per month, because I'm doing meters divided wait. For how many months? Oh no. The answer is just how many months? Oh, I'm sorry. Yeah, see, okay. I need to pay closer attention to what the question is asking. Okay, so 6.9 months. So about 7 months this has been going on. Okay, evaluate. 0.1 cubed. Huh, okay. Well, that's going to be 0.1 times 0.1 times 0.1. So how do we handle that? Well, let's handle it like we did before when we learned how to multiply by decimals. Just say, 1 times 1 times 1 is 1. Whoops. Let me just put it right below. And then count up all the digits that are to the right of the decimal point. Well, there's 1 digit there to the right, and 1 there, and 1 there. So a total of 3 digits to the right of the decimal point. So my answer is not going to be 1 or 0.1 because I need to have 3 digits to the right of the decimal point in my answer. So that means I got to slip in a couple of zeros here. And now I've got 1, 2, 3 digits to the right of the decimal point. 0.001 or 1/1000. Okay, and that makes sense because if you say, well, I've got $0.1 and I'm going to keep 1/10 of that. Now you're down. Now it's a lot smaller. Now down to a penny, and now I'm going to keep 1/10 of that. It just keeps getting smaller and smaller. So when you multiply by a number that's between 0 and 1, you're going to get something smaller every time. That's how it works. Okay, let's do one more. Okay, so 0.3 times 0.3. Well, 3 times 3 is 9. And we've got 2 digits to the right of the decimal places. So my answer needs to have 2 digits to the right. And now it does. 0.09, 9/100ths. And that's how we do it. All right. Now we're going to kind of mix it up a little here. Okay, so we're back to order of operations. So the order of operations, work inside parentheses first, then exponents, then multiplications and divisions simultaneously from left to right. Everything's left to right, and then additions and subtractions simultaneously. Are there any parentheses here? Nope. Are there any exponents? Yep. So 1.5 squared, if we do 1.5 times 1.5, that's going to be 2.25. I know because, well, I do math all the time, so I just know some of these things. Makes me really cool. I get invited to all the best parties. Okay, so there's no more exponents. Are there any multiplications or divisions? Yes. 4.7 times 0.6. Okay, that I don't know, and so maybe I'm not completely nerdy. So 6 times 7 is 42, carry the 4, 6 times 4 is 24, plus 4 is 28, and there's 2 digits to the right of the decimal point, so I'll put the decimal point right there at 2.82, which makes sense because basically what this statement here says is I want to keep 60% of 4.7. Well, 60% is only a little over half. So so our answer should be only a little over half of 4.7. All right, so we get 2.25 plus, and then the 4.7 times 0.6 turned out to be 2.82. And now we just add them together, and we get that, and everything's cool. And there's no units or anything, there's no story, so we don't need to put meters or miles per hour or anything. But that would be our final answer. So just follow the order of operations and let your conscience be your guide. All right, so Kira, I knew a girl in college named Kira. Nice girl. Kira buys a bag of 12 oranges for $3.48. Yeah, we sang in the church choir together. 12 oranges for $3. Okay. Find the unit price in dollars per orange, if necessary. Okay. So when they say unit price, they mean what's the price for one item? Okay. In other words, one orange. How much is each orange? Okay, that right there might tell you what to do. You might say, oh, yeah, I get it. I know what I need to do. If you don't, one thing that people tend to ignore, but is very important and useful, is the units in a word problem. Why is that important? Because that tells you sometimes what you're supposed to do. Okay, this statement here says we're supposed to take dollars and divide it by oranges because per means divide. It always does, it always will. When you say miles per hour, you mean miles divided by hours. When you say dollars per pound, you're taking dollars divided by the number of pounds. So dollars, it says do dollars per orange. So knowing how to read the units, that can give you a nice hint as to what to do. Basically, the units right here are telling you go do dollars divided by oranges. That's exactly what it's saying. It's like, really? That's almost like cheating, but obviously it's not. Okay, so 12 divides into 3.48. Let's see, 12 goes into 34 twice. Is that right? I think. Yeah. And then bring down the 8. And 12 goes into 108 9 times. And so it's going to be $0.29 per orange. Let's put a G there, I guess. And then it says, if necessary, round your answer to the nearest cent. Oh, okay. And I mean, you could write it 29 cents per orange if you want, but they said find the unit price in dollars per orange, not cents per orange. So we would want to do 29 cents per orange. But yeah, use those, use the units that they tell you to find things in. It helps you to know what to do. So you know for sure how to proceed.